This is a quick overview on Charles's law, one of the many gas laws. So Charles's law is important because it explains the relationship between temperature and volume. It also allows us to understand increases in volume due to change in temperature. So we're going to talk a little bit about the history of Charles's law, kind of where it came from, how it was formed. Then we're going to talk about Charles's law, the equation, everything like that. And then we're going to discuss a few practical applications of Charles's law and how we can use it. So by the end of this video, you should be able to identify Charles's law, accurately state the idea of the law, kind of the general idea, what it's trying to tell you. You should be able to name at least two historical figures with connections to Charles's law, as well as be able to successfully complete at least two different practical application problems related with Charles's law. So make sure you're able to do that. One of the first questions we want to ask ourselves is, why is it called Charles's law? This one's pretty self-explanatory. So going into the history here, it was first observed and recorded by Jacques Charles in 1787. He was a French experimenter. However, he did not initially publish his own findings. He didn't ever published his own findings. In 1802, Guy Lussac, another scientist, began research and refined Charles's observations. He used some improved experimental techniques in different mathematics, maybe some better equipment, things like that, and concluded that equal volumes of all gases expand equally with the same increase in temperature. Guy Lussac went on to publish his results, giving his credit to Charles, hence the name Charles's law. And also similar work was carried out around the same time by Dalton. So Charles's law states that for any gas at a constant pressure, the volume of the gas is directly proportional to its absolute temperature. It's a little graph showing that direct proportional relationship. So the general idea of Charles's law is, as temperature goes up, the volume will also go up. Also, as temperature goes down, the volume will go down as well. So it works either way. Now this is a cool little diagram showing an experiment that could be done to be an example of Charles's law. You have a hot plate increasing the temperature of a water bath that goes around a certain container full of gas. As that water bath heats up, the gas heats up, and the volume of that gas expands, hence pushing upward on that piston device. So to discuss some practical applications, first thing we want to look at is the equation. Volume 1 divided by temperature 1, so your initial volume and your initial temperature, equals your resulting volume over your resulting temperature. So V1 over T1 equals V2 divided by T2. So the first problem that we're going to do, we have a balloon filled with 8 cubic inches of air at 29 degrees Celsius. We want to know the volume of the balloon if the air temperature increases to 35 degrees Celsius. So we know that the volume is going to increase because our temperature is increasing. So our balloon is going to get bigger. So we know we're looking for a larger value. So the first thing we want to do is analyze. We want to know what we're looking for and what do we know. So we're looking for our volume 2, and we have three knowns. Our initial volume, we know our initial temperature, and we know our new temperature. We're increasing our temperature. Okay, so we want to go ahead and put all of our values into our equation. So we have our unknown. The volume 2 is our unknown. We have volume 1, we have temperature 1, we have temperature 2. So we want to go ahead and substitute, fill in those blanks. So we know we have 8 inches cubed. We know we have 29 degrees Celsius as our initial, and our temperature 2 is 35 degrees Celsius. So now we have our equation and we are ready to solve. So for step 3, we want to go ahead and solve. So just do the math. 8 inches cubed divided by a temperature. What we have to do first is add 273 degrees to convert the Celsius to Kelvin. The reason we do this is because in order to solve these gas laws, we need our temperature in Kelvin. Okay, so we're going to make that conversion, 302 Kelvin, 308 Kelvin. So we have 8 inches cubed divided by 302 equals 0.0265 equals x over 308. Okay, so x is our unknown. Now we just have to multiply both sides by 308. We get 8.162 equals x, because the 308 on the right side of the equation canceled out. So now we know our unknown, our volume 2, is 8.162 cubic inches. So our balloon has expanded by 1.62 cubic inches. Okay? So here's another problem that you can try on your own. Go ahead and pause the video and solve it out, and the answer will pop up momentarily. Here we go. We have 23.16 degrees Celsius is our new temperature. So if you're interested in more gas laws, Charles's law is just one of many, many gas laws. There are a lot more to explore. Now, the NAUI, National Association of Underwater Instructors Master Diver course, in particular, discusses this law and many others in detail. So if you're interested, you might want to look into a course like that. So what we talked about was a little bit of history of Charles's law. So remember that though the work was published by Guy Lussac, and Guy Lussac did do a lot of experimentation and work with the topic, Charles initially began the research and experimentation. Guy Lussac just refined it and published it. Guy Lussac did give Charles credit, hence the name Charles's Law. So we discussed what Charles's Law states. As temperature increases, volume increases, or vice versa. As temperature decreases, volume decreases. So remember that there's a proportional relationship between temperature and volume. We also discussed how and when to use Charles's Law. Remember, you need to add 273 to your Celsius value to convert that to Kelvin. You also need three known pieces of information to solve for your unknown. So those are a few things you want to keep in mind from this video. What we learned is that Charles's law states that as temperature increases, volume of gases will increase proportionally. Charles's law was developed by Jacques Charles, but was refined and published by Guy Lussac.